Let's get straight into this. Welcome to This Explainer. When you open up your Cambridge Mathematics past papers, whether we are talking about syllabus code 580, 0606, 4024, 4037, or 4040, and you flip to the mensuration questions, it is incredibly easy to just see a page full of abstract formulas, intimidating command words, and heavy exam requirements. It's overwhelming, right? Let me tell you about two types of students I see all the time. First, there's Alex. Alex overloads his answers with every single raw mathematical fact and formula he memorized, but he provides absolutely zero analytical structure. Then you have Sam. Sam rushes through the paper, completely misses the specific command word requirements, and throws away easy marks because the structure is just a mess. We are going to change that today. Our core concept is simple: make your mark. We want bold strokes of creativity backed by incredibly solid structure. What if I told you that the very geometry problems you are losing sleep over today are directly connected to the monumental, awe-inspiring achievements of ancient Egypt? Today, we are taking a fascinating journey. We are going to trace the art of measurement, mensuration, from the sweeping sands of the ancient world directly to your modern Cambridge mathematics syllabus. Prepare to see your geometry exam prep in a completely new light.
Look at this, the Great Pyramids. Looking at them really forces us to stop and ask a simple question. How on earth did they do it? The Egyptians must have been extraordinarily talented architects and surveyors. Thousands of years ago, without calculators, without modern lasers, and certainly without a printed syllabus guiding them, they successfully planned and constructed these massive, precise monuments. They achieved this by using early mathematics and sophisticated surveying techniques. They weren't just randomly moving stones around hoping for the best. They were applying practical geometry on a colossal scale. Think about Sam, the student who rushes. If the Egyptians built like Sam takes exams, rushing without looking at the core requirements, these pyramids would have collapsed halfway up. They needed a strategy. They needed a framework.
To build on that incredible scale, you absolutely need a standard unit of measurement. It's the foundation of everything. And to solve that problem, they actually used their own bodies. Enter the cubit. A cubit was the distance from the tip of the middle finger to the elbow, which averages out to about 50 centimeters. Evidence of this specific mathematical unit dates all the way back to the Old Kingdom around 2500 BCE. In fact, on a wall near the stepped pyramid at Meidum, just south of Cairo, guidelines for the pyramid's slope were found spaced exactly 1 cubit apart. It was the fundamental building block of their architectural math. Just like in your exams, if you don't define your base units and show your foundational working out, you cannot build a high-scoring answer.
Over time, this early physical math evolved into formal written records. We start around 2500 BCE with those physical pyramid building guidelines. But as society grew more complex, so did their math. By 1800 BCE, we see the emergence of the earliest true mathematical documents. Jump forward to 1650 BCE, and we get the famous Rhind mathematical papyrus. And by the time of the New Kingdom, stretching from 1500 to 100 BCE, they were meticulously recording complex land and dirt measurements. Mathematics evolved from physical sticks and body parts into formal, recorded academic texts. They were standardizing their knowledge. And speaking of standardization, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's keep moving.
So, speaking of those formal texts, look at this. This is a remarkable section of the Rhind mathematical papyrus, dating to roughly 1650 BCE. Now, the absolutely crucial point here is that this isn't just a record of taxes or kings, it is literally a mathematical problem text. Historians strongly believe it was based on even older works, and it consists mainly of mensuration problems and their solutions. It is highly likely that this was written by a teacher for their students. Think about that for a second. Over 3,500 years ago, an Egyptian student was sitting down, looking at a papyrus just like this, and trying to decode the command words to solve the exact same kind of area and volume problems that you face today in your 0580 syllabus. It is essentially the world's oldest past paper.
In the Rhind papyrus wasn't alone. There is an incredibly rich tradition of these early math documents, including the Moscow mathematical papyrus, the Egyptian mathematical leather roll, the Kahun papyri, and the Berlin papyrus, all dating to around 1800 BCE. Now, Alex, our hypothetical student, would probably just memorize all these names and dates without understanding the math within them. But the real strategy is in the application. My personal favorite example is the record from the workers' village of Derir el-Medina during the New Kingdom. Archaeologists found records there calculating the exact volumes of dirt removed while digging underground tombs. They were using 3D volume calculations, mensuration, for literal, everyday fieldwork. They didn't just know the theory, they applied it perfectly to their real-world exam. So, we've seen how the ancient Egyptians used the cubit to build pyramids and calculated dirt volumes for their underground tombs. But how does that ancient builder's knowledge translate into your modern world? How do we take those red pen marks on your practice papers and transform them into green check marks? Let's pivot from the sands of ancient history directly to the modern day. What are the mensuration problems we actually solve today, specifically in academic frameworks like the Cambridge Mathematics 0580 syllabus? Let's break down the modern requirements step by step and build that mathematics success blueprint.
We begin our modern journey with the absolute fundamentals. Syllabus section E5.1, Modern Measurement Fundamentals. This is where you set the foundation for your top-tier exam answers. If you mess up the fundamentals, the whole pyramid comes crashing down.
Just as the Egyptians had to establish the cubit before they could even think about building a pyramid, you have to master these core modern units: mass, length, area, volume, and capacity. The Cambridge syllabus doesn't just want you to know what these words mean in a dictionary sense. It explicitly requires you to use them in practical situations. You need to be able to seamlessly express quantities in terms of larger or smaller units. It's the modern equivalent of knowing how many cubits make up a pyramid base, but now we use a globally standardized metric system to ensure absolute precision across all our calculations. If a question asks for your answer in meters and you leave it in centimeters, that is exactly where you lose marks. Once we have our baseline measurements totally locked in, we level up. We move to syllabus sections E5.2 and E5.3, 2D shapes and circles. Now, before we dive into the specific strategies for 2D shapes, stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's look at how to tackle these shapes. There is a very distinct divide in 2D geometry, and this table perfectly illustrates where students like Sam tend to rush and make mistakes. On the left side, we have polygons, shapes with straight lines. You need to confidently carry out calculations involving the perimeter and area of rectangles, triangles, parallelograms, and trapezoids. But then, look at the right side. We introduce the circle. Circles don't have straight edges, so the rules entirely change. Perimeter becomes circumference. But the Cambridge syllabus goes much deeper. You must be able to solve problems involving arc length and sector area. Let's do a quick visual challenge, a data scan. Look at the formulas in your head. What's the trap? The crucial point is remembering to treat arc length and sector area as fractions of the total circumference and total area of the circle. It's literally about finding a specific slice of the pie. If you just write down the full area formula, the examiner puts a red line straight through it.
Now, we escalate the difficulty. We are moving into three-dimensional mathematics. Syllabus sections E5.4 and E5.5, 3D volumes and surfaces. This is where the heavy lifting happens and where the top grade boundaries are decided.
These are the exact mathematical principles you would need if you were planning a pyramid or digging an underground tomb today. For section E5.4, the expectations are extremely specific. For cuboids, prisms, and cylinders, you must master the volume calculations. For cuboids and cylinders, you also need the surface area. But notice that last bullet point. For the sphere, the pyramid, and the cone, you are responsible for calculating both the internal volume and the outer surface area. Let's do a speed writing challenge in our heads. You have 30 seconds to structure an answer for a sphere's surface area. How do you do it? You have to be able to look at a 3D object and mathematically define both the space it takes up and the skin that covers it, step by step. State the formula, substitute your values, calculate, and link it back to the correct units. That's how you guarantee maximum marks. Finally, we reach the ultimate test of mensuration. Section E5.5, Compound Shapes. This is where the training wheels completely come off. You won't just be handed a perfect cylinder or a simple triangle in the exam. You'll be given a complex, mashed-up object. This is our final system. Let's look at the steps to master this. First, decode the command word and identify the compound shape. Second, and this is the most critical skill, break it down into the known 2D shapes or 3D volumes we just discussed. Find the hidden rectangles, spot the hidden prisms. Third, apply your framework. Calculate those individual parts methodically and combine them for the total area or volume. Keep an eye on your time management here. Don't spend 20 minutes on a 3-mark question. It's a logical puzzle of deconstruction and reconstruction. Master this and your mark potential shoots up to 100%.
So, as we wrap up this explainer, I want to leave you with a final thought. The next time you sit down with a past paper to solve a problem involving the volume of a pyramid or the sector area of a circle, don't just see it as an annoying hurdle. You are participating in a human tradition that dates back 4.5 millennia. From the precise spacing of cubits at medium to the complex compound shapes on your modern syllabus, the language of mathematics connects us across time. Are you ready to master these ancient secrets and build your own mathematical monuments? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep practicing, keep breaking those shapes down, and I will see you next time.